Use more synthetic division. You choose or I will. Here it is. You cannot choose 16 because 16 cannot be, we cannot apply synthetic division on 16. You can choose 12. You can choose anything that has just one degree 1 in the denominator. Any other degree doesn't work with synthetic division. Even this and this, all these. So let's choose.
12.
Which one?
12.
You said 12. Perfect. Let's work on 12. In 12, we have x to the 4th minus 81 divided by x minus 3. Very good. Good pick. What goes in the box?
5 and 3.
Indeed. And now careful. Degree 4, degree 3, degree 2, degree 1, degree 0. 4, 3, 2, 1, 0. Bring down the first, the leading coefficient, always. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. 0 plus 9 is 9. 3 times 9, 27. 0 plus 27 is 27. 3 times 27 is 81. Yes, nice. Can anyone give us the final answer? Remember, we divided degree 4 by degree 1. This is the leading coefficient of what term? Anyone, please?
X to the 4th part.
We cannot. 4, 3, 2, 1? No. Degree 4 divided by degree 1 is degree?
3.
Yes. 3, 2, 1, 0. So x to the 3rd plus 3x squared plus 9x plus 27. And there is no need to write plus 0 over x minus 3. This is it. So always remember, when we divide degree 4 by degree 1, we get degree 3. Degree 3, degree 2, degree 1, degree 0. Is this okay? Are we comfortable with the synthetic division?
Can we go over one more, please?
Absolutely. That's why I already opened it. Please choose anything you want. Anything. As long as the denominator is 1, has degree 1.
Can you just choose one for us?
Yes. What about 27 or 28? Let's do 28. Okay. 28. X to the 7th plus x to the 5th minus 10x cubed plus 12 divided by x plus 2. They are in descending order. Can anyone tell us what goes in the box?
Is it -2?
Indeed. It takes care of all the sign changes that we did in the long division. Degree 7, degree 6, degree 5, degree 4, degree 3, degree 2, degree 1 and degree 0. 7, 6, 5, 4, 3, 2, 1, 0. Degree 7, degree 6 is missing. Degree 5 is there, but degree 4 is missing. Degree 3 is there, but degree 2 is missing, and degree 1 is missing, and this is the free term. Of course, this is extensive, right? You're not going to have something like this on the test, but it's a good exercise. 1. Negative 2 times 1. 0 minus 2. Negative 2 times negative 2. 1 plus 4. Negative 2 times 5. 0 minus 10. Negative 2 times negative 10. Negative 10 plus 20. Negative 2 times 10. 0 minus 20. Negative 2 times negative 20. 0 plus 40. Negative 2 times 40. What is it? Negative 68. Now, I divided degree 7 by degree 1. What is this?
Is it x to the 6th power?
Indeed, this one, minus 2x to the 5th, plus 5x to the 4th, minus 10x to the 3rd, plus 10x squared, minus 20x, plus 40. Degree 6, 5, 4, 3, 2, 1, no degree, minus 68 over x plus 2. No, you're not going to see something like this on a test. I'm not testing endurance. You know that. This is endurance. It's practice. How will I check? X times all these, plus 2 times all these, and minus 68. If I don't get the top, this makes no sense. It's incorrect. Are you feeling a little bit better about synthetic division? It's like a puzzle, basically. You have to follow the rules step by step. Do you think we need other examples, or can we move on to those two theorems that I was mentioning at the beginning? Theorems?
Is there a way to check the synthetic division, or do you not check
Same
that?
way. Exactly like what I just said. To check, you multiply x by all these 3, 2, 4, 6, 7 terms, and then you multiply all these terms by 2. Exactly there is no other way. Exactly how we checked on the synthetic division. And then on the long division, minus 68. And I have to recover this. If I don't, the answer is incorrect. You want to check? We can check. Emily?
Sorry. Yes, please.
Oh yeah, sure. I couldn't hear you. Sorry. Of course. So I distribute x to all these these millions of terms. X to the 7th minus 2x to the 6th plus 5x to the 5th minus 10x to the 4th plus 10x cubed minus 20x squared plus 40x. Now I distribute 2 plus 2x to the 6th minus 4x to the 5th plus 10x to the 4th minus 20x to the 3rd plus 20x squared minus 40x plus 80 and minus 68. When I perform all these calculations, if I don't get x to the 7th plus x to the 5th minus 10x to the 3rd plus 12, the answer is incorrect. So let's do that. I did get x to the 7th, so that's done. Now x to the 6th has to go away. Negative 2x to the 6th with 2x to the 6th. Okay, now we move on to x to the 5th. So this one, and nothing else. 5x to the 5th minus 4x to the 5th is indeed x to the 5th. Now, x to the 4th has to go away. Let's see if it does. Negative and positive. No other x to the 4th, gone. X to the 3rd. So 10x to the 3rd, and that's it. 10x to the 3rd, negative 20x to the 3rd is negative 10x to the 3rd. Okay, now x squared. Negative 20x squared with positive 20x squared has to go away. They did. 40x with negative 40x. And 68 minus 80 minus 68 is 12. And there is nothing else. So we recover these 4 terms. Everything else is gone. So therefore, the answer is indeed minus 68 over this. Exactly the same procedure as always. It's like, again, 10 divided by 3 is 3 plus 1/3. 3 times 3 plus 1 is 10. Exactly, that's exactly what I did, but it looked horrible because there were so many terms to multiply. Okay. Let's suppose I have a polynomial divided by x minus a. So this is a typical situation for the synthetic division. Typical. So in this situation, if I have a polynomial divided by x minus 5 or x plus 10 or x minus 3, whatever, let's suppose I am only looking for the remainder. Let's say I do not need the quotient. How would I just determine the remainder without finding all that long quotient? So the remainder of the division of polynomial divided by x minus a is the polynomial evaluated when x is a. So here's another way. I cannot use this for the previous situation that we had. No, I cannot determine anything here. And when it comes to the remainder. The remainder is an expression of x. So only in the situation in which I have cases in which the synthetic division is applicable, like this one, and I am not interested, assuming I am not interested in the quotient, I can immediately determine the remainder. Here's how. And I am going to go back to just the previous example. And let's say you're giving me this division, and you say, I don't care for the quotient. Just find me the remainder of this division. Okay, in that case, I'm going to copy this polynomial, which was x to the 7th plus x to the 5th minus 10x to the 3rd plus 12. And you only want me to find the remainder. So the remainder of the division will be the top polynomial evaluated at -2. And what was the remainder? -68. So I better get it. So I'll go back to the calculator. You know me. I'm going to put in the I worked on something like this with another student today. Good. I'm going to punch in the polynomial x to the 7th. And then plus x to the 5th. No, never mind. Okay. Plus x to the 5th. Minus 10x cubed. And then plus 12. When I punch in -2 in this polynomial, I must get -68. That was the remainder that we just determined. We knew the answer. So, indeed, -68. So this is something called the remainder theorem. The remainder theorem says that the remainder of this division, if I divide by x minus a number or x plus a number, is the value, the polynomial evaluated when x is a. In this case, the division was this polynomial divided by x plus 2. All I had to do is plug in the polynomial -2 to directly and immediately get the remainder, assuming I was not interested in the quotient. Now, something called factor theorem. And I'm going back to, I think Brent chose that problem a few minutes ago. I just want to go back to it. Hopefully I can find it. I know I have everything here in the correct order. Where was it? It was in the synthetic division. I remember it. Yes, right here at the top. So notice that this division of x to the 4th minus 81 over x minus 3 did not have a remainder. So I'm going to start by explaining with this example, on this example. So the remainder like before, is this polynomial evaluated at 3, and the answer was 0. So notice that it's the same setup when the synthetic division is applicable. The remainder of this division, like before, is p of 3, this polynomial evaluated at 3. 81 minus 81 is 0. In that case, when the remainder of such a division is 0, we say that x minus 3 is what for x to the 4th minus 81? Is a what?
Factor.
Exactly. So when the remainder of such division is 0, and I know how to find it now, right, from the remainder theorem. When it's 0, this means that x to the 4th minus 81 has a factor. It may have more than one factor, but definitely of x minus 3. Guaranteed. So I would like us to choose a couple of examples. I'm going to share my book again. Here it is, next page. To illustrate the remainder and the factor theorem. They're cousins. They are well related. So I would like us to look at any of these problems, and I'll explain what this means in a moment. So let's choose one. Anyone would like to choose, or I will?
36.
That's exactly what I was looking at. 36 is good, 395. And in 36, we have a polynomial that is 4x to the third plus 5x squared minus 6x minus 4. And they're talking about something of f of negative 2. Okay. So what they're really saying is that we have this polynomial 4x to the third plus 5x squared minus 6x minus 4 divided by, if it's f of negative 2, what do I have in the denominator?
Is it x plus 2?
Indeed, that's it. So this is nothing else but the remainder of this division. That's what it is. If this number, f of negative 2, if it equals 0, what will you say about x plus 2 for 4x cubed plus 5x squared minus 6x minus 4? What will x plus 2 represent if, I don't know yet, if it is 0? Exactly. And this is a very powerful theorem. Here's why. Do you remember when we had, for example, x squared minus 1 over x plus 1? Well, x plus 1 is a factor of x squared minus 1. Why? Because if I replace here, negative 1 squared minus 1 is 0. So the remainder of this polynomial, when I plug in negative 1, it will be 0. That's why this is a factor of x squared minus 1. So let's put in the polynomial in the graphing calculator, plug in negative 2, and then decide, is x plus 2 a factor or not? If the remainder is 0, it's a factor. If the remainder does not equal 0, this is not a factor. So in the graphing calculator,